So how is your classes is going? So am I audible?
Yeah.
Yes.
So this let's start it then.
Yeah. Yeah.
Okay. Hello everyone. So today we are going to discuss the concept of electric dipole. And basically we are going to do some derivations. What is the electric field due to an electric dipole and what is the potential due to this? And then we will solve some previous year gate questions. We also try to visualize the concept of electric dipole so that we can handle the questions much better way. So let's start it with an electric dipole. But the last time someone told me that we will first uh, let you know what is the question that we are going to discuss. So this question is coming in GATE 20. This question was coming in GATE 2019, and this is based on the concept of electric dipole, where the charges combination is such that it will form an electric dipole, and basically we have to find what is the electric field due to this dipole. In the second combination, the charges are again form electric dipole, but in this case we have to find the electric dipole moment. And third question is also regarding the electric dipole moment. And the fourth question says we have to find the electric field due to the dipole moment. So these are the questions that is coming in, that was coming in previous year from 2019, 2017, 2015, and then 2013. So we will do that questions once we are understand the concept of electric dipole clearly. So basically, the electric dipole is whenever a pair point charges of equal magnitude have a very small separation and they are placed together, they form an electric dipole. So basically, the electric dipole is some electrons and make the hydrogen more positive charge and oxygen will become more negative charge. So this type of combination is also form an electric dipole in natural system. There are other some cases like antenna system, they are also electric dipole. So the displacement of charges create a dipole. This displacement of charges will create a dipole. So there are certain topics that we are going to discuss. First is what is the electric field due to dipole? But most of the cases, the electric field created by a dipole is highly dependent on in which direction we are going to create. For example, we are going to calculate the electric field. For example, we might want to calculate the electric field at certain angle or at perpendicular location or in the direction of axial directions. So we have certain cases like what is the electric field as the axial line of the dipole or what is the electric field at equatorial line of dipole or what is the electrostatic potential. So the best way to calculate the electric field due to dipole is with an electrostatic potential is due to the electric dipole. So best way, first thing is what is how do we measure the electric dipole of a system? For example, we might have plus Q charge, minus Q charge, they will form the dipole. And we also have plus 2Q charge or minus 2Q charge, they also form the dipole. So how do we derive what is the strength of the dipole? It is given by electric dipole moment, which is the charge Q, whatever. Charge q multiplied by the distance d. The charge q is a scalar quantity. Sorry. So the charge q is multiplied by d. This will form our electric dipole, and the is a vector quantity. It's always from positive charge to negative charge. So, and the SI unit of this electric dipole is coulomb meter. So first we derive the expressions for the electric potential due to the dipole. So most of the cases when we are trying to solve the problem regarding the dipole, we are working in spherical polar coordinate. And we will see that doing most of the calculation in spherical polar coordinate make it easier to understand this concept. So in spherical polar coordinate, the basic thing that we have to understand is the angle theta is with respect to the z-axis. We have a point P which is at a distance r, and it will make an angle theta with the z-axis with the polar angle, and the on the xy plane it will make a projections which make an angle phi with the positive direction of x-axis and the y-direction. So these are r theta phi coordinate of in spherical polar coordinate. So what we do is we assume our electric dipole in z directions, and we wanted to for example we have minus q charge and plus q charge, and we have any point P here at which we wanted to calculate what is our electrostatic potential. So if it has r plus distance from the positive charge and r minus distance from the negative charge, and from the center of these charges the distance is r. So we have to calculate what is the electrostatic potential. We use the superposition principle, which says that the electric potential is due to the positive charge 1 upon 4 pi epsilon naught q upon r plus, and due to the negative charge 1 upon 4 pi epsilon naught q upon r minus. The problem is just simple derivation. Maybe you have done that before, r plus r minus. So you can assume that each will make an angle theta with the z-axis. So we can use here the Law of cosines, which says that if we have this case, if somehow it is arises that we have an angle theta, and we know the sides A, B, C, so we can always write this like c square equals to a square plus b square to ab cos theta. So in our case, this c is, so we wanted to know what is our r plus in terms of r, and we know that the distance between them is d, and the half of it is d by 2 here. So we know this distance, we know r plus distance. We just want to know this r plus in terms of d and r. So if you look at this, then distance which is like opposite to this theta angle, this is r plus. So here this is r plus, and this distance A here is D, and this distance B here is R. So we can always write our R plus square as R square plus D by 2 whole square minus 2 into R into D by 2 cos theta. Similarly, we can write for R minus square as R square plus D by 2 whole square minus, so therefore it will be plus 2R D by 2 cos theta. So when we do these calculations, we can just write r plus minus as I have taken all plus and minus both these things together. So we will take r square as 1 minus plus d by 2. I have taken r square d by 2 whole square. Actually, sorry, it's a plus square and minus plus d by 2. This will cancel out, and d by r cos theta. So this quantity then will become more of like a r squared. So this will become r squared 1 plus t squared by 4 r squared minus plus t by r cos theta. So if you look at this d by 4r square for the case when d is much smaller than r. I'll take note. For the case when d is much smaller than r, which is generally the condition, like if we have two charges which are places at centimeter distance apart and we wanted to calculate what is the electric field like at a kilometer distance apart, that in that case distance d, which is the distance between charges, is always going to be less than r. So in that case, this term will turn us to be 0 and r plus minus square will become r square 1 minus plus, it is approximation, d by r cos theta. So when we put this equation, we wanted to know 1 by r plus minus square. We are left with 1 by r square. I have just taken 1 by of this equation. So we are left with 1 minus 1 plus d by r cos theta minus 1. And if since we wanted to know what is 1 by r plus and 1 minus 1 by r minus, so we wanted to we will just take square root on both sides and we are left with 1 by r 1 minus plus 3 by r cos theta to the power minus 1 by 2. And we can expand this as 1 plus x to the power minus 1 by 2. So the expansion will reduce this minus plus sign and we are left with 1 plus minus 1 by 2 due to this exponential factor into cos theta. So a 1 by r plus will become 1 by r 1 plus d by 2 r cos theta, and similarly 1 by r minus will become 1 by r 1 minus d by 2 r cos theta. And when we calculate 1 by r plus minus 1 by r minus, which is necessary for our potential, we are left with 1 by r 1 plus d by 2 r cos theta minus 1 by r 1 minus d by 2 r cos theta. So this term will cancel out this one and we adjust these two from get added. So we are left with d by r square cos theta. So when we wanted to calculate our potential V of R, we are left with 1 upon 4 pi epsilon naught Q 1 by R plus and 1 minus R minus, which is d by R square cos theta. So our potential VR due to dipole will become QD cos theta upon 4 pi epsilon naught into R square. So if you look at the this figure, which I can draw it again, like we have two charges and at a distance r, this make an angle theta. So our potential electron dipole is in the z direction, and this is our point r. This is plus q. This is minus q. So this and the distance between them is t. So this angle cos theta is nothing but the angle between p vector and the r vector. So we can also write this qd as p vector and the cos theta angle is r vector upon 4 pi epsilon not r square. So if you look at the p vector is qd vector, which is the direction which is in z direction, and r cap is the direction which is the radial direction, which make an angle theta. So whenever you calculate this p vector dot r cap direction, you will get p cos theta. So we can always write this the potential Vr due to the electric dipole moment as p cos theta upon 4 pi epsilon naught into r square. It's so this is the potential. So we want also wanted to know what is the electric field. So the electric field, as you know, is given by negative gradient of V vector. So electrostatic field is a special kind of field whose curl is zero. It is zero as long as electric field is not varying with time. So their curl will become zero. And there is this theorem which says that whenever we have a vector whose curl is zero, it always can be written as a gradient of some scalar. So from which we say that the electric field is given by negative gradient of P vector. So in spherical polar coordinate, if we wanted to calculate gradient of P, it can be written as del V by del R in the r cap direction plus 1 by R del V by del theta in the theta cap direction plus 1 by R sine theta del V by del phi in the phi cap direction. So if you look at your V vector, V potential, and you calculate del V by del R, it's become del by del R of P cos theta upon 4 pi epsilon naught R square. Here, all these quantity are independent of R, only this quantity is going to be differentiated. So we are left with minus 2p cos theta 4 pi epsilon naught into R cube. And similarly, we can also calculate del V by del theta, which is del by del theta of this quantity. Here, all these quantities are remain constant, only theta dependence is going to be differentiated. We are left with p sine theta upon 4 pi epsilon naught r square. So when we put back into this negative gradient of p vector equations, the electric field E is comes out to be negative will get cancelled, and there is one r that is also coming due to this one. So we have p upon 4 pi epsilon naught r cube. There is 2 cos theta, which is then r cap direction plus sine theta in theta cap direction. So this is our electric field due to a dipole. And as you can see, it is very much dependent in which direction or at which point we have calculate our electric field. For example, the initial figure that I have shown to you, the electric field due to a dipole is something like this. It is started like you have positive charge and you have negative charge. The electric field line is started from positive charge going towards the negative charge. This is how the electric field lines flow. So they are going away from positive, they are going towards the negative. So if you calculate the electric field along the axial direction in which the dipole is placed, the field value is different. If you calculate the equatorial direction, field value is different. If you calculate any other direction, field is different. So you can see that from the formula as well. Your electric field is highly dependent on theta and also in r and theta cap directions. So, for example, if I wanted to calculate along the axial direction, this is my dipole, and in this direction, plus q and minus q, and I wanted to calculate what is the field in the same equatorial direction. In that case, their angle between the z-axis and the theta is zero. Z-axis and the r is zero, so theta is zero for the case of axial case, and the electric field is then given by 2p vector for pi epsilon naught in the r cube. And this is the z cap direction since we have taken the angle z in the z. And what happened if we are talking about perpendicular direction? That is, we are talking about the direction which is perpendicular to this dipole moment. Then the electric field is given. In that case, theta will become 90 degree with z axis. So electric field is given by P vector divided by 4 pi epsilon naught into r cube theta cap direction. Generally, it is shown, written as theta cap, but it will be in xy plane wherever the projection will came. So this is the electric field due to the electric dipole. Now come to, there is also a way we can write this equation, which is the equation 2 in mode of coordinate free form. Like you do not want to write in spherical polar coordinate. So you can always write this your electric field as 1 upon 4 pi epsilon naught 1 by r 3 p vector dot r vector in the r cap direction minus p vector. This is most, this is not generally used, but this can also be possible. And how we can write it? In that case, we have to assume that, let's say our p vector, which is our dipole moment making an angle theta with the z axis. So we have what we do is we just okay. So we have it's not P vector actually. Let's draw it again. For example, you have a z direction and you have a dipole moment, positive charge and negative charge, and you have your dipole moment in this direction z. But you wanted to write know what is the in r cap and theta cap direction. So you kind of separate its component in one in the radial direction and one in the theta cap direction.
Ma'am,
But
there will be
let me
r
say
cube
what
1 upon 4 pi epsilon 0 r cube.
here, yeah, there will be
Yeah.
r cube. Sorry. In this case, there will be r cube. So, can I write this, how this equation came from this equation, or you will understand it? It's coming from that the dipole moment P is decomposed into two components, one in the radial direction, r cap, and which make an angle theta, and another is in the theta cap direction. So this is the r cap direction, and perpendicular to this is theta cap. So P vector can be written as mod of P equals theta in the r cap minus sine theta in the theta cap direction. So if you put that thing here, for example, P vector dot r vector, this quantity will comes out to be only this component will survive. Theta will become zero because r and theta are perpendicular. So whenever you wanted to calculate r dot theta cap direction, it will be zero. R cap dot theta cap. Actually, it's not r cube because I have taken here is the r vector. So if I take r cap, which is r vector divided by magnitude of r, in that case it will be r cube. For example, if I calculate here p vector dot r vector, it will be t cos theta, and there is r also due to this r mod. Means this is how it is calculated mod p mod r and cos theta. So you are left with PR cos theta here. Actually, it is not R vector. It should be R cap direction. I have done mistake here. Sorry, this is concept is little. So this is not the R vector, it's R cap direction. Only then this concept will be true. This equation will be true. You can check it. So when you calculate P vector dot R cap, you are left with P cos theta in the R cap direction, and three times of it get multiplied. So you are left with three times of P vector dot R cap in the R cap direction as 3P cos theta in the R cap. And you have to subtract minus P. P is this. So minus P means P cos theta in the R cap minus minus plus sine theta in the theta cap. So you are left with 2P cos theta in the R cap plus sine theta in the theta cap direction. So this quantity is exactly the same quantity that is written here. So yeah, only then this equation makes sense. So this equation 2 and 3, they are both similar, but this is in spherical polar coordinate and this one is in normal coordinate. You can use in XYZ Cartesian coordinate as well. So now comes to, let's say, kind of, if you understand the derivation part, we can do more of a visualization part as well. Means how these things will going to play role when we try to visualize the electric field due to a dipole. For example, if I am going much distance away from these, like they are centimeter, millimeter apart, and we have to calculate the field like kilometer distance apart. So for us, they will look like tiny, tiny dots. And if we have one charge which is opposite to another, what will be the electric field lines? Are they going to be same like due to the dipole, or are they going to be much different? So there is one animation that is given. You can also play with this. I will give it the link to you. Okay. So in this animation, what they do is we are given negative charge -1, and they are given positive charge which is +1. So the electric field will be more like a dipole electric field. Now what I'm saying is now change my electric field, my charge plus Q. So now I have +2Q charge. Let me see if I can change their color so that you can see more clearly. See, the orange one lines are due to positive charge and the blue one due to negative charge. So I have changed one of the charge to +2. And what I am going to do is I am going much far away. And as I am going much far away from this dipole, they are look like a more of a much closer to me. So see, the electric field line will become like a straight lines, very much like the electric field due to a single charge. So it is confirming us that if the charges are not equal, the electric field lines will not be look like that of dipole. They will become more of a electric field line due to single charge, and the net charge will, in this case, will become yes, something happened. So in this case, your net charge electric field will then become what is your total charge. If your charges are not equal, then electric field is proportional to the total charge, and you can just do the superposition principle, what is the electric field due to single charges, and add them. But in the case will become interesting if you have charges which are equal, like the condition as we before. Even if I will go much distance away, it will again stay like this electric field due to a dipole. It will not going to change even much distance away when they are become so tiny that we can assume that they are just one charge. Still, the field lines will become like the field line due to dipole. So in the case of dipole, the electric field is proportional to the charge and the distance between them. For example, if I change the distance between them, the field lines in the outer region will become much denser, which shows that as the distance between them get increases, the electric field lines will become denser and the strength of the electric field will also increase. And if they become much closer, the strength of electric field at a far distance will become kind of decreases. You can play with this animation yourself. It's a nice animation I have found. So in the case of the electric dipole, the electric field charges not only distance, electric field not only depend on the charge, but it depend on the multiplication of charge and distance q. So which is obviously the electric dipole moment of the system. So this is the main point that we have to consider whenever we try to solve the problem, gate problem, using the concept of electric field. Now we can go towards solving our problem. I hope you understand this concept and the derivation. The rest, if you have question, you will ask when the questions
Ma'am, what
will
will
be
be the direction
completely
of the
solved.
electric dipole?
The direction of electric dipole generally taken to be the z direction. Once you fix the direction of dipole, it will become easier to calculate the electric field direction. So you always try to make your direction to be the z direction. Most of otherwise it is just if you have positive charge and minus q charge, it is in this direction. It is away from positive. Sorry, it is towards from positive to negative. So this is the direction of electric dipole. But when we are trying to solve problem, we always align our dipoles such that your dipole movement direction will be in z. So your charge is like that, positive here and negative here. Are you able to get it?
Ma'am, direction of electric dipole will be from minus to plus or plus to minus?
Plus to minus. It's always
No.
electric field lines originate from negative, going away from positive, and they are always going towards the positive, negative. Sorry. Okay, I will explain clearly. It always going away from positive and going towards the negative. So this is the direction of electric dipole moment as well. Is it clear?
Ma'am, direction of electric dipole moment will be minus of electric field.
If they are inside dielectric medium.
Okay.
If I am getting it clearly, if they are inside dielectric medium, then the direction will be opposite. Otherwise, it is always originate from positive charge to negative charge. Okay, you are right actually. I've done mistake. Sorry, it's from negative to positive. It's confusing. I will let you know actually where I have done mistake. So this is the direction of dipole moment from negative to positive. Yes, you are right. Thank you for correcting me. So can you solve the problems?
Yes, ma'am.
We have half hour left. So this is the question that is coming in GATE 2019 exam. Consider a system of three charges minus q by 2, minus q by 2 and q. And we have to find what is the electric dipole potential in volts at any point r comma theta. So here these two charges minus q by 2 and minus q by 2 and they are placed at a distance 2d. So the total combinations minus q by 2 minus q by 2 they will form a complete charge combination of charge q placed at a distance d and similarly you have a charge q placed at a distance d. So this kind of combinations then make a figure very much like electric dipole moment. So we have to find the electric dipole moment due to this. We have to find electric potential. Sorry, actually I'm too confusing today. So we have given the distance r. It is given to be 10 meter. We have given theta. It is 60 degree. And we have given the charge q, which is 10 raised to power minus 6 coulomb. And the distance d, which is 10 raised to power minus 3 meter. So we have to find the electric potentials. So best way to solve the problem is just to check whether it is making an electric dipole moment or not. For example, and the best way to calculate is for the case of monopole, as I have told you, we have just combine is depend upon summation over charge q. So we have to see the summation of all the charges. So we have three charges Q1 is minus Q by 2, Q2 is minus Q by 2, and Q3 is Q. So we have given three charges here. So we just take the sum of them, summation over all these charges. We are getting minus Q by 2 minus Q by 2 plus Q. So this will become 0. So there is no monopole here. So electric, so we will check it is the case of dipole or not. And to check the case if it is the dipole or not, which is directly proportional to the QI DI. So we have to calculate the distance as well. So our charge minus Q by 2, it is placed at a distance D in the y direction, which is negative. So it is Q into T, but negative y direction. Then there is another charge minus q by 2 which is plus d direction. So there is a charge minus q by 2 to d which is plus y direction. And there is another charge q which is in z direction at a distance d. So we have plus q charge into d in the z gap direction. So in this case, our dipole is minus q d by 2. In the y cap direction, it is plus minus q by 2 d phi cap plus q d z cap. This quantity will cancel out. So we have a finite value of electric dipole. So the potential that we are going to calculate is due to the electric dipole. And the potential we have calculated is p cos theta upon 4 pi epsilon naught in the r cube direction. Not the direction, it's a scalar quantity. So we are given P, which is Q into D. Q is given 10 raised to power minus 6 Coulomb. D is given 10 raised to power minus 3. Theta is given 60. So we put all these quantities here and the potential V is then calculated as 10 raised to power 9 Q T cos 60 divided by R cube 10 meter cube. So if you calculate this quantity, you can try yourself. This will turn out to be 0.045. So the potential that is going to be came here is 0.045. You can do the calculation yourself. So is that question clear to you? It's not an hard and fast, it's a formula-based question. The main point here is you have to check either they make a dipole moment or they make a monopole moment. And this always you have to do for any type of question in which involve dipoles. I hope is it clear to you? And the same question is coming in GATE 2017 as well, where three charges combination is given. One is 2 Coulomb, minus 1 Coulomb, and minus 1 Coulomb. They are positive X, this is negative X, and
Hi,
so
one
there
minute.
are both those positives.
You have solved this question. So you have taken potential is equal to 1 by r cube term, but that should be r squared. Yeah, here this r
R
cube.
cube is for, sorry, R cube is for electric field.
Yeah, yeah, yeah.
Yeah,
So
I
the,
have that.
v should be p cos theta by yeah r square. So answer yeah yeah
Yeah, R square.
yeah yeah
So I have done calculation for the R square.
yeah, yeah.
Thank you.
Okay.
The next question, okay. So in this question, there is given that this distance is 1.5 and it's an equilateral triangle with 1 meter side. So this one is also 1 meter and this total is also 1 meter. So this is zero point 0.5 and since this is 1 meter, this is zero point 0.5. So this 1 coulomb charge is at a distance of 1 meter. So we have to find the component of electric dipole moment along the y direction. So we have to know what is the electric dipole moment that is going to form in the y direction. The questions require two concepts in this case again. For example, first we have to check, even though they are already given that it's an electric dipole moment, so we do not have to check that it's a monopole or not, since it's going to be zero if we do summation over Qi. So we have minus 1 coulomb charge and minus 1 coulomb charge plus 2 coulomb. So this is going to be zero. So we are started with a dipole. So dipole in this case for this 1 coulomb charge, it is placed at a distance of 1 meter on x-axis. So when we calculate Qi for the charge T vector, it is minus 1 coulomb at a distance of 1 meter in the x-cap direction for this charge. And this is minus 1 coulomb charge of 1.5 meter, and in y direction we have to know what is this distance. So it is 1 meter hypotenuse and 0.5 meter base. So we can calculate this distance if we took this as right angle triangle. For example, we can take this as a right angle triangle, and we have known its hypotenuse base. So we know what is this. This will be 1 minus zero point 0.5 square. So it's another coordinate in y direction is 1 minus zero point 0.5 square. So we have 2 coulomb charge, which is multiplied by 1.5 in the x cap plus 2 coulomb charge square root of 1 minus zero point 0.5 square distance in the y cap. So this is our dipole completely. But they have asked us what is the dipole moment along y direction. So whenever they ask us what in certain direction, so best way is just to project your dipole in that direction. And projection means you have to take the dot product with that direction. So the vector dot y cap will give the dipole component in the y direction. Since x cap multiplied with y will give 0, this component also gives 0. This one is also gives 0. So the only component that will survive is this. So the component of dipole moment in y direction is given by 2 times 1 minus zero point 0.5 square. So this will become 2 times square root of 1 minus 0.25. This is 2 times 0.75. You can calculate what is this value. I haven't calculated completely, but that will be your answer. Are you able to get it? Then there is this question. A charge minus q is distributed uniformly over a sphere with positive charge q placed at its center. So we have a sphere at the center of which contain positive charge, and minus q charge is distributed uniformly at around this positive charge. And the same is the case for the second. However, in this case, it is the ellipsoid which surrounds this positive charge q. So they are expected that it will be like a situations of electric dipole, since we have positive charge q and negative charge q. So they are expecting that there will be a case of dipole here. So we have to find with respect to the origin of coordinate system, which one of the following statement is correct. The electric dipole moment is zero in both case, and the electric dipole is non-zero, zero in first, non-zero in second, non-zero in both. So if you look at this situation and you wanted to calculate what is the electric dipole at a certain distance far away, so you just wanted to calculate what is the charge QI RI. The positive charge is at center. However, the charge negative charge is also surrounding it. So whatever the lines that is originated from charge Q is again terminated at the negative charge in this region. So whole combination of charges will just originate from in the origin and terminate on this sphere since they are all equal charges. So the no lines will be coming in this region. So electric dipole moment is zero in both cases. So this is the correct answer in these situations. And you can understand the concept if you want to from Gauss law perspective. What is the total charge inside? But here they have not talked about the electric dipole with in the question. Just they ask what is the electric dipole in the options. So now come to this next question. This coming gate 2013, they are given two charges and placed opposite side of origin. For example, delta x minus x naught, how is it looking? If you have origin at x equals to x naught, you have a peak. So at this position, this is finite, at all other position it is zero. So you have placed a charge q at this position and at this position that the x minus x naught at x equals to minus x naught there is a charge minus q. So this is the kind of charge distribution. So they are wanted to ask what is the electric field at 2x naught. So the electric field has to be calculated along the axis. So it's like a more of a continuous charge distribution. So the problem gets can be solved by using electric dipole moment P is equals to initially we do this QI but in case of continuous we can also do Ti is replaced by X and the charge is replaced by charge density rho dx since it is a one dimension case. Otherwise it will be volume element multiplied by dV. So here the electric so electric dipole moment is given by integral of x rho dx. So when we put this quantity of rho inside this integral, d is equals to x. Charge q is constant, so we take it outside integral. X minus x naught plus x naught plus minus x plus x naught into dx. The integral from minus infinity to infinity. But if you look at the charge distribution, it is zero from minus infinity to infinity. There is only charge as minus x naught and plus x naught. So the integral minus infinity to minus x naught is zero. So we can take minus x naught. So minus infinity to minus x naught integral is zero. Plus q minus x naught to plus x naught. There is a finite charge distribution at minus x naught and plus x naught. So we have a charge minus x naught to x naught as a delta function. Delta x minus x naught minus delta x plus x naught and outside x naught to infinity again it is zero. So you can also write x naught to infinity is zero. So only this integral we are talking about. So the electric dipole is q equals q integral of minus x naught to x naught delta x minus x naught delta plus x naught into dx. So this integral will give you q x naught. Say delta x is equals to x naught. I have forgot to take into account this x also. So you have at x equals to x naught, there is a positive q and minus delta x equals to minus x naught. So this will make it plus and q into x naught. Since x is changed to x equals to minus x naught here and x is equals to x naught here. So the dipole moment due to this charge distribution 2q x naught. And we have to calculate electric field at 2x naught. So the potential due to this is comes out to be 2q x naught upon 4 pi epsilon naught into x square. So the electric field is minus del V by del x. So that will be 2q x naught 4 pi epsilon naught x multiplied by 2. And it will be x cube. So it will be, I think my fourth option is 4qx naught pi epsilon naught x cube electric field in the escape direction. If I have the option that is given with x cube is just 1 and all other are x square. So question is just you can see the power of x. You can tell better the question. And we have to calculate it at a distance of x is equals to 2x naught. So electric field is qx naught in the escape direction by epsilon naught 2x naught cube 2x naught cube. So it will be 8. Why it is saying 4 pi epsilon naught x cube. The correct answer will be q upon 8 pi epsilon naught x naught is upper and 1x naught cube here, so then it will be x naught square in the escape direction. So this x naught will cancel one power of this. So what is the answer in 8? There is no answer in it. Even with x square. So this is the correct answer. I don't know why it is not given in option. There is something wrong with options. You can check. The answer will be coming in x square, but this one has to be 8 and the option is not given. You can check if I have misplaced somewhere too, but the idea is same and the question is going to be same this solve this way. You can mm, try to solve it yourself if you can find the correct answer. The basic methodology is going to be same. So with that, I think if you have any doubt, you can ask me, even in this question. So are you people have any doubt or you got it?
No, ma'am.
You haven't got it.
Yeah.
So should I explain it again?
No, no. Clear.
You got it clearly?
Yeah.
Okay. So whenever you encounter the problem related to electric dipole, so you always try to see whether it's due to the dipole or due to the monopole. And if it is due to the dipole, try to find the dipole moment using this. And then solve the potential or electric field problem. This is the basic idea behind this question. I hope you will get it. Then we will meet in next class. If you have any doubt, you can ask. Okay, guys. Then see you in next class.
Thank you, ma'am.
Okay, bye bye.